Hi, this is Walter Stone, and this is Unit 6, Lesson 4, and we're working with factoring polynomials. And this lesson is about factoring a polynomial completely, and we'll probably follow up this lesson with a lot of practice in class. So we'll practice this general strategy for factoring polynomials. Now that we've factored out a common factor, we've looked at x squared plus bx plus c types. We've looked at ax squared plus bx plus c, those types, those trinomials. We've looked at trinomial squares, differences of two squares, differences of two cubes. So we want to put all of this together and have a general factoring strategy that will help us factor polynomials. So the general rule first is in A here, you always want to look for a common factor. That's a big deal here. We always want to do that. Part B says consider the number of terms of the polynomial. So if it has two terms, then look to see whether it's a difference of two squares or a sum or difference of two cubes. And if it has three terms, we want to see if it's a square of a binomial, or if it's not, we can use trial and error or factoring by grouping. And if it has more than three terms, we want to try factoring by grouping or look for any differences of squares. And the last step here, part C, we always want to factor completely. So if we still see a factor that can be factored, we want to factor that as well. Okay, so here we have some guided examples, and here I have 10a squared x minus 40b squared x, and I see that 10 is a common factor of both 10 and 40, and I see that x is a common factor of both of these terms, so that's why I factored out a 10x. And when I factor out that 10x, I have a squared minus b squared multiplied to that 10x. That has two terms. It's a difference of two squares, so I can keep factoring. So I'll have 10x times a plus b times a minus b. And now that polynomial is completely factored. So we factored out the common factor, and we factored the difference of two squares. So when you see that kind of problem, you want to make sure that we factor that completely. In guided example 2, we have x to the 6th minus y to the 6th. And this looks like a difference between two squares. And we have x cubed squared minus y cubed squared. So we can treat this like a difference of two squares. And when we do that, we have x squared plus y squared times x squared minus y squared. And these both turn out to be, this first factor turns out to be a sum of cubes, and the second factor is a difference between cubes. So the first factor we can use the sum of cubes formula. So that's going to be x plus y times x squared minus xy plus y squared. And x cubed minus y cubed will factor as x minus y times x squared plus xy plus y squared. Okay, so now we've factored those completely. Now sometimes we might come along a sum of two squares, and the only factoring pattern we have for now is a difference between two squares. So if we're factoring over the set of real numbers, we really can't factor this. We can factor a difference, but we can't factor a sum yet. So if we can't factor a number, it's known as prime. So if we can't factor a polynomial, it's a prime polynomial. So a sum of two squares cannot be factored over the real numbers. So this is a situation where we would say prime is this is a prime polynomial. So what you want to do is try these 4 examples and go ahead and follow these factoring guidelines. and factor these polynomials, and then come back after pausing the video and you can check your work. Okay, so in problem 1, I saw a common factor of 2, so I multiplied 2 by 1 minus 16x to the 4th. And 1 minus 16x to the 4th is a difference of two squares. So I have 2 times 1 minus 4x squared times 1 plus 4x squared. And 1 minus 4x squared is also a difference of two squares. So I can factor that as 1 plus 2x times 1 minus 2x. So we have 2 times 1 plus 2x times 1 minus 2x times 1 plus 4x squared. Remember, we can't factor a sum of two squares. So this is a prime factor and the other factors are prime. So we have the complete factorization. In part 2, in problem 2, we see that 7 is a common factor. So 7 is multiplied by a to the 6th minus 1. And that can be thought of as 7 times a cubed plus 1 times a cubed minus 1. And a cubed plus 1 factors as a plus 1 times a squared minus a plus 1. And a cubed minus 1 factors as a minus 1 times a squared plus a plus 1. So we have 7 times a plus 1 times a squared minus a plus 1 times a minus 1 times a squared plus a plus 1. In problem 3, I did a factoring by grouping type of thing. So I grouped the first two factors and I saw that 3 times x plus 4 gives me 3x plus 12. And I see that x is a common factor of 4x and x squared, so we have x times 4 plus x. By the commutative property, x plus 4 and 4 plus x are really the same factor. So we see that x plus 4 is multiplied by an x and by a 3. So I wrote that out as x plus 4 times x plus 3. And in the last problem, I saw that c squared minus 2cd plus d squared is a binomial square. It's a trinomial square. It's c minus d squared. If we factor out a negative from the second three terms, we have the opposite of t squared plus 8t plus 16. And so that's like minus t plus 4 squared. So this looks like a fancy difference of two squares. So we'll have c minus d plus t plus 4 times c, that should be a c minus d each time. C minus d and a c minus d minus t minus 4. T plus 4 here. So this should be c minus d plus t plus 4 times c minus d minus t minus 4. So if you can correct that, that will make sure we have the correct factors. Professor Stone is not perfect sometimes, and so I now see that I should have had a minus here and a minus here. Okay, so now that you've tried those, try the written exercises on the next page, and we will work on these types of problems in class as well. Okay, see you then.